Hello everyone, today my topic is erythropoiesis. So what is erythropoiesis? Erythropoiesis means the red cell formation. How red cells are going to form. From hematopoietic stem cell, how red cells are going to form, today I am going to discuss about it. So, first of all, the hematopoietic stem cell. So, this stem cells are present in bone marrow, and they are going to differentiate various types of poietic cells. Just like erythropoiesis, for erythropoiesis they form committed erythroid progenitor cell. They are going to differentiate and form committed erythroid progenitor cell. Okay, this cell is committed, they are engaged to form RBC. They are not going to form other types of cell, they are only committed to form erythroid series cell. Okay, so this hematopoietic stem cell have various capacity. Okay, they can they are self-renewal property, they have self-renewal property, they have different they have the property of differentiation, they have the property of multiplication, they have self-renewal. This means one stem cells to other stem cell, they are going to differentiate other, they are going to multiply, and by this differentiation property they are going to form committed erythroid progenitor cells. So by this committed erythroid progenitor cell they are going to form different types of erythroid precursor cells and ultimately going to form mature RBC or erythrocyte. Okay, so I am going to talk about step by step. And this committed erythroid precursor cells, proerythroblast, form or we can talk as pronormoblast, similar name. And they have some properties, they have some morphological features. So we can identify in the bone marrow which is proerythroblast, which is early normoblast, which is intermediate normoblast, which is late normoblast. Okay, so they have certain morphological features, different morphological features you can easily understand by staining. Okay, so they are large in size, they are large cell. They have in the nucleus, they have one or more nuclei. And the cytoplasm color is stained in blue cytoplasm. Why blue? Why blue? Because of ribosomal RNA and the uniform fine chromatin pattern. Okay, proerythroblast to early normoblast or basophilic normoblast. comparatively smaller in size. Coarse nuclear chromatin, here fine chromatin, here coarse chromatin. And cytoplasm is specific. Please everyone write down. The next step is from early normoblast to intermediate normoblast or polychromatic normoblast. Now the nucleus is small. Nucleus is smaller in size. Chromatin clamped. Appearance of hemoglobin. So there is admixture of the blue RNA and pink hemoglobin. So they are going to, this is a polychromasia. This is polychromasia, and the blue cytoplasm due to RNA and the pink cytoplasm due to hemoglobin, and this blue and pink mixture, okay, blue and pink admixture mean the mixture of basophilic and acidophilic staining. Okay, this means I'm explaining this. Basophilic means basophilic staining for ribosomal RNA, for nucleic acid for base staining, okay, acid for base staining, and for hemoglobin this is base, and for hemoglobin there is acidophilic staining. Okay, so for hemoglobin, this for more hemoglobin there is pink stain, and for more RNA, just early phase this is blue cytoplasm. Blue cytoplasm means there is lots of RNA, ribosomal RNA, and for blue cytoplasm and this stage, this polychromatic normoblast, there is admixture of pink and blue, okay, blue RNA and pink hemoglobin. So this color is polychromatic. This color is polychromatic. This is blue and pink mixture. Okay. So polychromasia. The staining property. Okay. The mixture of pink hemoglobin plus blue rRNA. Now from this late normoblast or orthochromatic normoblast. They have pycnotic nucleus. Pycnotic. And this nucleus is present in eccentrically, not in center. Eccentrically. Cytoplasm stains pink because there is lots of hemoglobin. Due to hemoglobinization. The next step is reticulocyte. This is the intermediate step. The upper step is late normoblast and the below step is erythrocyte. This is the intermediate step. So this features is interesting. They have the nucleus is ultimately expelled in this step. Okay, the nucleus is ultimately expelled from orthochromatic nucleus and with the formation of reticulocyte. The formation of reticulocyte. Nucleus is ultimately expelled from this orthochromatic nucleus. There is presence of nucleus is orthochromatic normoblast too, but the nucleus is pycnotic. Pycnotic, all know pycnotic. Okay. The above step is nucleus is smaller in size, chromatin clamped. Now coarse nuclear chromatin. The above stage is fine nuclear chromatin. Okay, ultimately the step is pycnotic nucleus and this nucleus is ultimately explained from orthochromatic normoblast. With the formation of reticulocyte. And why this name reticulocyte? Why this name? There is still there presence of reticular fine chromatin in the cytoplasm. Okay, reticular pattern. There is chromatin. So bluish tinge in the small bluish tinge in the cytoplasm. Okay, so very little rRNA present in the cytoplasm. The ultimate step is erythrocyte or mature RBC. After 1 to 2 days in the bone marrow and 1 to 2 days in peripheral blood, reticulocyte loses RNA and it becomes mature pink staining erythrocyte. Erythrocyte is pinky. Okay, so in the bone marrow, the reticulocyte 1 to 2 days and the peripheral bloods 1 to 2 days. So by this way reticulocyte ultimately form into erythrocyte. Thank you everyone. That's it.